Hi guys, welcome back. Going to cover section 2 today, and I got to tell you, this section right here is probably my favorite section of 8th grade science to teach. There's so many fun demos to do for the gas laws in this section. I'm so bummed you guys aren't in the classroom right now. I'm looking out at empty desks and you're not here to see this live. I am going to post, or I'm going to film a separate demo video and try to share these with you. I know it's not the same, but make sure you watch that video as well. All right, that was weird. So gases can be measured. They've got properties that can be measured. There's volume, there's temperature, and pressure. Volume is just how much space it takes up. Temperature is obviously the temperature, but more scientifically than that, it's that energy of the motion of those particles. Okay, the faster they're moving, the higher the temperature. Okay, pretty standard by this point now. And then pressure. If the gas is in a confined space, which it pretty much always is other than the atmosphere, those gas particles are bumping into the container. Well, that bump, that outward force is pressure, and it can be measured, okay? So we're going to go through 3 laws with those 3 measurements, okay? But we're gonna relate 2 of them at a time. So we're gonna start with pressure and volume. What that means is that temperature is constant. Temperature is unchanging when we talk about pressure and volume, okay? This is known as Boyle's law. And with Boyle's law, basically it states that when the pressure on a confined gas increases, the volume decreases. And then vice versa also. If the pressure decreases, then the volume increases. Now this should make sense to you if you can kind of visualize this. If you have a container that's filled with a gas, if you could squeeze that container from the outside, the volume is going to go down. Now, those gas particles are going to get closer together and they're going to take up less space, so the volume is going to decrease. As the pressure increases, the volume decreases, okay? That's what's known as an indirect relationship. As one goes up, the other goes down, okay? And you can just kind of see it visually here. Pressure goes up, volume goes down. Pressure goes down, volume goes up, okay? Now, if you've ever tried to unstack buckets before, buckets get really stuck together, and it almost forms like a suction, but since science doesn't suck, we know that there's a different explanation. So as you're pulling the buckets apart, what you're doing is you are increasing the volume. There's a little bit of air between the 2 buckets. So by pulling them apart, you're increasing the volume. Well, you can see that these work in the opposite way also. If you increase the volume, the pressure is going to go down. If you decrease the volume, the pressure goes up, okay? Because they're more cramped together in there. So by pulling the buckets apart, you're increasing that volume in the space between the buckets, which has low pressure. So then the higher pressure on the outside is pushing. High pressure is always pushing to low, and so the outside environment is pushing that bucket together. The top bucket you're trying to remove is being pushed back into place, and that's why it's so difficult. So if the buckets get stuck, what you need to do is you need to stick something down along the side of the bucket, and it allows the air pressure to equalize, and then they pull right apart, no problem. Weather balloons. These are used now for people to use GoPros, and they make these really cool videos of the GoPros going way up out into not outer space, but like really high up into the atmosphere. As elevation increases, as altitude increases, the air pressure is going down. There's less air, so the volume of the balloon can increase. Well, eventually the volume of the balloon will increase so much that the balloon will pop, and then that's what allows those GoPro videos or those weather instruments to come back to the surface, and people can collect those, okay? All right, moving on, next one. Now we're going to talk about pressure and temperature. So volume is constant, okay? So this would be in containers like rigid containers, not something like a balloon. A balloon can change its volume. So we're talking about things like canisters, like propane tanks, glass bottles, or real heavy rubber, okay? So the volume does not change with these 2. The book doesn't talk about a law name, but this is actually known as Amundsen's law, and it states that when the temperature goes up, so does the pressure. This is a direct relationship. They both increase together or they both decrease together. And this should make sense to you, okay? We've talked about temperature being the energy of the motion of the particles. Well, the higher the temperature, the more movement there's going to be. So the more movement there is, the harder they're going to be crashing into the container that they're in. So as the temperature goes up, that crashing into the container also goes up. That's measured as pressure, okay? Again, temperature goes up, pressure also goes up. Temperature goes down, those particles are going to kind of huddle together a little bit. They're going to kind of condense closer together, so they're not going to push on the container as much. The volume won't change because the container can't change, but the pressure will go down, okay? And then we see this in tires. Tires don't really change their volume because it's a rigid material. They can get flat because there's less pressure in them. But this is also this is why you're warned not to throw like canisters, like aerosol canisters or like oxygen tanks or something like that. They're not supposed to get too hot, because if the gas inside heats up too much, it's going to increase the pressure and it's going to push on that canister, and eventually the canister will fail, and it will fail with an explosion. Okay, so don't try this at home. All right, third one, we're left with volume and temperature. So now pressure is constant, okay? So this is in containers that can change. So as the particles, are moving around, yes, they're going to bump into the container more, but it's not going to result in more pressure. It's going to result in the container getting bigger, okay? And this is known as Charles' law. When the temperature of a gas goes up, those particles are going to move around more, and it's going to cause the volume to increase. If the temperature goes down, so vice versa, if the temperature goes down, the volume goes down. Again, faster moving particles spread out more, bigger volume. Slower moving, lower temperature, get closer together, lower volume, okay? Another direct relationship. They both go up together, temperature goes up, then volume goes up, temperature goes down, volume goes down. You might notice this in a playground ball. Like a softer one, not like a basketball, that's pretty rigid, but a real thin-walled ball might actually stretch and shrink a little bit. Balloons certainly do this with temperature. If a balloon gets too hot, it will actually pop, and if you stick a balloon in the freezer, it will actually shrink a little bit because the gas particles get closer together, okay? All right, so I have a trick for you to relate all three of these things together, okay? You can use a popsicle stick or a ruler or anything that's straight that you can write on. I'm using a ruler because it's easier to see. And basically you're going to cover the one that's constant, okay? So I'm going to cover temperature. That means we're talking about pressure and volume. So what happens when pressure goes up? What happens when volume goes up? Pressure goes down. What happens when pressure goes up? Volume goes down, okay? So now let's cover volume. So volume is constant. Now we're going to be talking about pressure and temperature. What happens when pressure goes up? Temperature also goes up. What happens when temperature goes down? Pressure also goes down. And then the last one, if pressure is constant and we're dealing with just temperature and volume, what happens when temperature goes down? Volume also goes down. What happens when volume goes up? Temperature also goes up. So just a little tool for you to help remember those relationships of those things, okay? Again, look for the demo video. You'll see a lot of this stuff happening in person, all right? See you guys later.